Hi, this is your host Sapin Bhartia, and today we have with us Frederic Branczyk, founder of Polar Signals. Frederic, it's great to have you on the show.
Thanks for having me.
It's my pleasure. Today we are going to talk about recent eBPF report survey as well. But before we go there, I would love to know a bit about the company because you're founder of Polar Signals. So tell us a bit about what is the company all about. And before the interview, we started talking. You said the company is 3-4 years old, so it's relatively newer company, which means that you still find some problems in the market which are to be solved, which led to the creation of this company. So let's talk about the history and the story of Polar Signals.
A little bit about myself, and that kind of is what ultimately snowballed into starting the company. So I've been working in kind of all things observability for the last 10, 12 years. Some people may know me from some of my work as a maintainer of the Prometheus project. I also created the Prometheus operator, the Kubernetes stack. These are kind of some of the most popular ways to run Prometheus on Kubernetes. And kind of everything in that intersection of Kubernetes and Prometheus was my thing for a very long time. So I started all of this through my job at CoreOS. I don't know if people still remember CoreOS. And ultimately, CoreOS got acquired by Red Hat. And when that happened, we kind of were at CoreOS already starting to explore the wider observability space. And so I was kind of immediately in charge of all things observability at Red Hat. And kind of one thing led to another where, I was leading this group of 35-ish engineers that were doing kind of cutting edge metrics, logs, tracing, and then OpenShift, the kind of Kubernetes platform from Red Hat. All of these things are kind of naturally extremely performance sensitive, right? And so we found ourselves profiling our software all the time. And for those who are maybe not familiar with profiling, profiling is kind of as old as software engineering itself. Basically, it allows us to see down to the source code line number where resources are being spent. That can be CPU, that can be memory, or whatever other resources we may spend with our compute. And knowing where these resources are being taken allows us to, actually optimize the source code. And kind of, I think the inflection point for me was I read this paper that Google published a couple of years before that, where they were talking about how Google is always profiling every single process across all of their data centers all the time, and all the amazing benefits that they were getting out of that. And I think that kind of immediately clicked for me because, I was doing observability, I was doing profiling, and I kind of connected the dots as continuous profiling was kind of the same evolution as where we went in the 2000s from like Nagios checks to time series based alerting with Prometheus or Datadog, right? And so continuous profiling was kind of that same evolution for me, kind of systematically going about profiling and making it observability, just like all these other things that we're doing with observability. I got incredibly lucky and got to present the whole thing as a keynote at KubeCon in 2019. And that ultimately then snowballed into me starting the company in end of 2020.
I would also talk a bit about this case study that you folks, around eBPF. Talk a bit about the deployment of eBPF, of course, looking at the whole history that you just talked about, not only yourself but all the Polar Signal as well. What prompted you to pursue this?
Before we specifically dive into the KubeSonnet project, I think it's useful to give some context on eBPF and Polar Signals. So our entire product is essentially built using eBPF. The entire profiler that we've built is using eBPF. And this is kind of what allows us to do very low overhead profiling across just about every language that you can think of. And so partly I will say we went to eBPF as a tool because we're really familiar with it, right? We work with it day in, day out. And just to set the scene, so what we're talking about here is a case study that we've recently done with the eBPF Foundation on actually a different project that doesn't have anything to do with the product we create and offer to our customers, but it's we were facing a challenge where we were essentially seeing a large chunk of our Google Cloud bill, but this would be the same on AWS. A large chunk of it was cross-zone traffic. So this is traffic where, process A is in zone A and process B is in zone B. And if they communicate with each other, all the traffic that crosses the zone boundary actually costs per gigabyte on cloud providers. And this is problematic when you run a service like ours that moves intense amounts of data, right? And so it's really important for us to keep as much data communication within the same zone whenever we can. Like I said, we noticed this on our cloud bill, but the first thing that we kind of realized was in order to be able to improve this, we need to be able to measure it. Where is this traffic coming from? And ideally, we would see it down to the pod level. So that we have a better idea of which workloads are causing this, right? Maybe we'll even come eventually to a point where we can profile it. I don't know. But for us so far, it's been good enough to know which workloads are the offender. But yeah, basically we needed to figure out how can we measure this on a per workload basis with low overhead. And ideally with all the metadata that we need. And so we kind of put this tool together that with eBPF uses NetFilter, and it basically hooks into NetFilter. It does require us to use a very specific version and configuration of Cilium. Again, this is something that we built for ourselves to solve a very concrete need that we had. And so we only solved it to the extent that it was necessary for us. Every GKE cluster, however, out there that is using data plane v2, which is the Cilium data plane, will be able to use this project as is. But of course, we'd be open to contributions from other folks if they want to kind of add support for other configurations. But again, we kind of solved it for ourselves. The eBPF program essentially intercepts all packets that are routed. We get the source and destination IPs. These agents that are kind of collecting this and watching this, then send that to a central server, and the central server resolves the pod IPs to the actual pod names, so that we can then figure out, okay, which nodes are those pods on, so that we can then figure out which zone is that pod in to ultimately determine, was this cross-zone traffic or was it not? And so with all of this information, we could then build Prometheus metrics that allow us to understand, which pods are causing the most cross-zone traffic. And then we actually also added the ability to not just see it on a per pod basis, but also we have flow logs that tell us exactly to which other pod did this go. And this was kind of important because one of the offending things that we saw was our main database, which a lot of services in our infrastructure interact with. And so we needed to know, is there a particularly large offender? And indeed, there was one service that was moving particularly large amounts of data out of our database, basically. And that was actually just completely unnecessary. So once we understood that it was this workload, we understood, okay, this workload only does one kind of interaction with this database, and it was really easy to optimize. So yeah, for us, it was also a combination of, we know eBPF really well. we know the Kubernetes ecosystem incredibly well, and we know the Prometheus ecosystem really well. And so that's partly why we chose those technologies, but it also, because of our familiarity, allowed us to put this together in 2, maybe 3 days. And it ultimately allowed us to reduce our cloud bill already very significantly, and we're on our path to basically having almost no cross-zone traffic ever.
And as you are, working on this, did you look at other solutions also? What was that you found that eBPF was the best option to address this challenge that you just talked about?
If you look at the repo, the whole eBPF code is like 90 lines of code, right? And the majority of that code is actually just struct definitions to be able to communicate from eBPF space to user space. And so eBPF just allowed us to hook the program at exactly the right trigger to get exactly the information that we needed, right? Without having to work through complicated systems that may expose way more information that we need, right? This is the kind of the strength that we see time and time again with eBPF. We can grab exactly the information that we need at exactly the point in time and in the system where we need it. And I think that's kind of eBPF's superpower. And this is what allows you to write relatively small programs to do pretty incredible things.
If there are other folks who are in the same kind of boat that you were, what would be your advice to them?
I mean, if you're in exactly the same boat as we are, use the project that we put together. Otherwise, I think that when we started with eBPF in 2020, 2021, the ecosystem was pretty bare. So it was pretty rough to get started back then. Now there are some pretty awesome tools available for just about any ecosystem that you're moving in. There is a really popular library called libbpf. C++ programs can use this. There's libbpf-rs for Rust. The Cilium folks have put together an awesome library for Go. I've seen that there's this one guy from SAP who compiles Java programs to eBPF bytecode. There's a huge ecosystem nowadays, so kind of get started and write your first eBPF programs. Maybe you can even start using just BPF trace, which is a cool kind of small command line utility where you can write small scripts to extract the things that might be interesting to you. And maybe only then you make the jump to actually writing these C programs. But yeah, I think kind of just get started within your ecosystem. I'm sure there are tools and libraries already available for your ecosystem. And just kind of get your hands dirty, because this technology allows you to do really incredible things with pretty small amounts of work.
I mean, you are involved with eBPF, but what kind of plans you have for future with eBPF?
We already offer our entire product using eBPF. So it's really natural for us to kind of grab eBPF whenever it feels like it's the right tool for the job, just like we did with this project, right? Just like we did with our product. And so, while we don't have any concrete plans for like building new projects or something, I think eBPF continues to be a really awesome tool for us for kind of low-level Linux work, wherever we need to do any kind of observability, basically, right? So I think there are a lot of really interesting things already happening in observability with eBPF, but I think we'll keep coming back to this topic, because at the end of the day, what we did here was also observability using eBPF, right? And I think this is something we'll continue to see.
Of course, we are trying to break the old silos, but it's kind of creating new soft silos, and it's not about silos, more about there will be specialized field. So, but when it comes to observability, how are you seeing the scope, whether we talk about just monitoring, tracing, logging, or it's going into security performance? So What role do you see of observability in the whole cloud stack?
This is also kind of our personal take at Polar Signals. We think that this is going to take a couple of years, but I think the next evolution of observability products that we'll see are going to be much less siloed, in the sense that we're already starting to see databases that are specifically created for observability purposes. And so we can have one database that stores all kinds of observability data. And so I think this is something that'll be the first layer. I think that'll have that kind of evolution. But I think as soon as on the database layer this happens, we're going to start to see this kind of move up the stack, and the whole experience of observability is not going to be anymore, I'm looking at logs, I'm looking at metrics, I'm looking at tracing, I'm looking at profiling data. We think it's kind of going to be a unified experience across everything. Again, I think that there are some pretty huge challenges to get to that point, but we're already seeing first signs. There's a really interesting company that Datadog just acquired called QuickWit that was kind of going into this direction. But we're seeing a bunch of other databases in this space that by like very young companies, ourselves included. We actually also created a columnar database ourselves called FrostDB. And we're actually currently working on the next iteration of this. It's kind of a general purpose enough columnar database that you can store all kinds of observability data in it, but it's not general purpose in the sense of like ClickHouse, where you can do genuinely everything you want with it. It is still scoped to observability data. There are other kinds of databases, databases in this space that I could name, but I guess what I'm trying to say is I think this is what we're already starting to see the beginning of, and I think this is only going to get more.
Frederic, thank you so much for taking time out today to join me today and not only talk about, of course, Polar Signals, but also how you folks, of course, are leveraging eBPF and also building the tools around these open source technology. Thanks for sharing those great insights, and I would love to have you folks back on the show. Thank you.
Thanks for having me.